What's up everybody, Jonathan here. In this video, we're going to talk about KNN. KNN stands for K nearest neighbors. It's an algorithm used in machine learning, and it determines based on the majority of the K nearest instances, the output. So basically what's close to the input, it determines the output. So the KNN algorithm is based on the idea that similar instances are likely to belong to the same class or have similar output values. To make a prediction for a query instance, KNN calculates the distances between the query instance and all instances in the training data. Then it selects K nearest instances based on this distance and determines a majority class for classification or average value for regression among the K nearest neighbors. So it's an instance-based learning algorithm. It does not create a model that can be explicitly understood, unlike algorithms such as linear regression or decision trees. Instead, the algorithm simply stores all the instances in the training data and uses them directly to make the prediction. This makes KNN a relatively fast algorithm as it does not require any training process, but it also means that KNN is not as scalable as other algorithms and can become slow when the training data size is very large. Okay, so there are kind of the benefits and drawbacks. So, good for small data sets, or maybe not even good. How about just better? That's probably the simplest way you can say it. Better for smaller data sets, worse for large, and better and worse relative terms. So let's go over a real world example. And before we get into it, hit the like button and hit the subscribe button. Let's go right. Let me clean this up a bit. Okay, like and subscribe. We'll keep that right at the top. So we're going to do import numpy as np. We are going to do from SKLearn datasets import load iris from SKLearn model selection import train test split, and from SKLearn neighbors import that one, K neighbor classifier. So we're going to start by loading the iris dataset. Loading iris dataset, and iris equals load underscore iris x uppercase x equals iris, and then data lowercase y equals iris target. And then we're going to split the data into training and testing sets. X underscore train, X underscore test. You're going to see this a lot in machine learning. Sorry, I'm scratching my eye right now. Y underscore train, Y underscore oopsie doodle test equals train underscore test underscore split uppercase X lowercase y test size equals, we'll call it 0.2, and random state equals 0. So that'll create our testing data, or our training data and testing sets. And then we're going to train the KNN model. And KNN equals K neighbors classifier. And then we're going to set n neighbors, which is something you can fine tune depending on what you're trying to accomplish, but that's going to set the number of neighbors. And then KNN.fit, and then we're going to pass into it, you guessed it, save some typing here, xtrain and ytrain. Clean that up a bit. And we're going to test the accuracy of the model. accuracy equals KNN dot score X test and Y test, X test and Y test, and we're going to print. And that's going to be accuracy colon space curly brace 2F. Oh, where's the period? The period button's not working. Dot format. Accuracy. Looks right. And we'll print. Accuracy 97. So there you have it. That's how you you created your data set, and you train it, you test the accuracy. Let's see what happens if we play with this number a bit. Unchanged. Yep. Anyway, thanks for watching, and if you have any data that you want to test this on, send it my way and I'll make a video about it. And don't forget to like and subscribe. Thank you. Bye-bye.